Oh God.
Just couldn't walk.
Yeah, it just literally just completely flexed, and I was like, oh well.
Oh, that's weird. Like locked up.
Yeah.
Oh wow. I've had that with like my toes. You ever get that when like one of your toes does something weird and all of a sudden it's just like.
My mom gets it. I don't get
No,
it.
my mom too.
She gets that too.
Yeah.
Yeah. It's
So-
you don't get that.
No, I get it in my calf.
Oh wow. Oh. Yeah. I get it in my throat, and I used to get it really bad. Yeah, it would be bad. Like something would catch in here, and then every time I'd swallow, it would just get worse and worse, and the pain was really fucking horrible. And like a couple of days ago, something happened like that. I learned how to snap it out. I could like snap the tendon or something weird. Oh good, this is all on video. Anyway, does anybody need one of these upper level? You've probably all got like multiple copies of that already. Cool. Today's going to be a little different, but good. I thought we would basically work on the next homework assignment together in here today, and kind of make it. Hopefully, we get done with it in here today. Does that sound good? Because I kind of want to move on also. If you do have your homework assignment today, I'll take it. If not, if you need more time, that's okay. It's okay.
It's actually because I don't know where my stapler is.
I got one on my door.
I
Send
went,
it to me.
I went to the
I just
nice
don't
little
have a
lady down there. I said, hey, you got a stapler?
I just pulled
It's not
it
a
apart.
No, I'm liking it. I already saw it and I was very happy. Thank you. Made me very happy, Sid.
Some of the words I've ever used on half a sentence.
Yay! On the bar. Alrighty, friends. So, Kyle, if you want, we can touch base tomorrow by Zoom if that
Yeah,
works
yeah,
for
that
you.
works.
Okay, awesome.
Yeah.
We'll figure out the.
I just gotta get a drug test either today or tomorrow.
You got to do drug. Oh, do you test like randomly?
Well, it's for my promotion at Lockheed because I'm moving places. I have to get a drug test.
Oh.
So I have to. God, and there's never a free moment in life, so it's just all over the place. I'm gotta figure out when I can do it. It's just pain.
Is it just like a urinalysis or a hair test? Or something?
Urine, which I'd much rather have hair, to be honest. Because if I don't need to pee, I'm just gonna be sitting there waiting.
Alrighty, so we will need our books together today, or whatever facsimile of book. Kyle, did you bring your book?
I did.
Oh, look at that. Alrighty. Cool. So let's do a little bit of review just to warm back up from our longish break. Pretty standard break. What is that? Let's just refresh our memory. Strengthen our memory.
The group of all permutations on the symmetric group. Or the symmetric group, I guess.
Nice. And what is, so this is the symmetric group, beautiful. And there's two N's in there. And then what is that?
The group of all permutations on, I guess, the integers. It's like a little set, it goes like 1, 2, and then all the way to n.
Yeah, on the set 1 through N. Cool. That works. Yeah, I don't know why I did that. What's a permutation? What is a permutation? Still like intuitively, what's a permutation? We do need to have this conversation. This is good.
Does that have to do with like the 1-to-1 and on-to function?
That's,
definition?
yeah, yes, absolutely. Can you, like, just in like lay terms, what is a permutation? Here's a cup. Here's this, whatever the hell that is. Here's a pen. Here's a book.
Rearranging.
A rearrangement, right? So here's permutation. Yeah.
Good word for it. Not at all.
Beautiful. So rearrangement is perfect, right? So it's a rearrangement of these numbers in here. And we had a couple ways to describe those. We usually use like a Greek letter to describe it. So we can think of it, let's say I had 1 through 5. This is the S, this is from S5 right now. And I wanted to describe the rearrangement where the 5th element moves to the 1st place, the 3rd element moves to the 2nd place, the 4th element moves to the 3rd place, and then some things start to, let's see, what else do I need to do? The 3 there, maybe the 1 there. So this is telling me that, yeah, the 1st element is moved to the 5th place, the 2nd element stays still, 3rd element shifts to the right one, 4th element shifts to the left one. Notice how these are just transposing. You see that? And 3 and 4 are just flipping places. And also 5 and 1 are just flipping places, right? Does that make sense? That's happening? How can I write this in cycle notation?
So, 1.
1 goes to 5.
Close it.
Because 5 goes to 1, right? So yeah, and then
2 is just by itself.
2's by itself. 3 and 4. Swap. And do I need to include that too? Don't need to include that, because if we already know we have a set of 5 things, then we know the 2 isn't getting touched. Cool. So this observation that I made at the beginning about how, notice how this was just a transposition and this was just a transposition and this wasn't nothing, is kind of a key to a hidden structure inside these things. So I wanna go down that kind of a tool, I guess, like a tool to discern things about these, what do they call it? Permutations. Things I have to look back up. I gotta warm up too. But this is kind of the key fact here. Every permutation can be written. So first off, as we got 2 different things, as a composition of disjoint cycles. That's what we just did, right? Yeah, disjoint cycles. So we spent a lot of time with that last time, or a little bit of time. But then also as a composition of transpositions that aren't necessarily disjoint, and also a composition of transpositions. And a transposition is just something, it's a 2 cycle. 2 cycle. 2 cycle. You've got like an A1 and A2, and they just flip places. So, you know, what that would mean is that A1 goes to A2, and A2 goes to A1. Flip, swap them. So there's a couple of ways to do, there's actually a lot of different ways to do this. Let me show you the basic formulas, and I still have to look at these to make sure I don't screw them up every single time. I think I got it. So let's say I'm in SN and I've got A1, A2, A3, I've got a cycle, A sub n. In the book they use commas. I wasn't using commas, but it's okay to put commas in here. To me it looks a little vector-like, so I kind of like to leave the spaces in there. So the first way to do this, as we notes, is to write it as these transpositions, A1 and AN swap, so swap the outer 2. Then swap the first one with the second to last. Then the first one with the third to last. And all the way up until you get to A1, A2. Transpose those. And this is kind of weird. Like, I've honestly spent a lot of time over this weekend, or since we met, thinking about this. It's very, very strange, but let's put it to action. Example. Let's take this one here. No, that one's not very interesting. That one's already like kind of done. So that's a little bit boring. So let's say I had 1, 3, 4, 2, 6, 5. So this is an S6, clearly, or maybe not clearly, but see that that's in S6 if we think about the fact that there's 6 freaking things there. So what this says is that I can rewrite this as the following transpositions. First I take 1 goes to 5, then 1 goes to 4, then 1, to 6, 1 goes to 2, 1 goes to 4, and then 1 goes to 3. So it's this kind of peeling like this. And it honestly, I'm still not sure I believe it, but it is true. Because it looks really weird. But notice that these are not disjoint at all. So it's not a disjoint cycle decomposition, you know. And let's actually maybe talk about how this works. So this original one, because it's easy to see it sometimes like this. Here's the original setup. Oh wait, no, that's not it at all. Don't write that down, that's garbage. That is utter garbage. Let's write it in this matrix form here. So I've got 1, 2, 3, 4, 5, 6. So 1 goes to 3, 2 goes to 6, 3 goes to 4, 4 goes to 2, 5 goes to 1 with the wraparound, 6 goes to 5. So this is actually the first original permutation. Let's think about why it's equal to that over there. So this is this one here. And is there any questions about how I got that? Take a moment and wake up your brain cells and make sure that that's registering.
Can you do it one more time?
Okay, yeah, absolutely. I sensed that. I sensed from the looks that we haven't had enough coffee yet today. That's okay. So just reading the cycle notation, this tells me that the first thing goes to the 3rd place, and then the 3rd thing goes to the 4th place. Does that make sense, like how to read this? This cycle notation, maybe that's where, is this where the trouble, tell me where the trouble is. Like understanding the cycle notation or going from there to here.
Okay, yeah, I see it.
Do you see, yeah, so Trinity, so check, do you see, yeah, you see it now? Okay, awesome, cool.
Yeah.
You would tell me, you wouldn't lie to me. Never, no? Okay, awesome. Beautiful. So let's take a look at each of these. So 1, 2, 3, 4, 5, there's 5 of those. So we've got the original state, and we're gonna have to do this in reverse order, right? Composition works this way. So actually, the first thing I do is I swap 1 and 3. So this is the 1, 3 swap right here. And then I'm going to apply the 1, 4 swap here. Now realize this means the positions, whatever's in the 1st and 4th positions gets swapped. It may not be 1 and 4, the numbers, but this is about positions getting swapped. So then when I do the 1, 4, and I'm actually just gonna kind of make this as a big flow. This will be easy. So right now for the 1, 4, I'm gonna take 1 and the 4th and swap those. So that's the 1, 4 swap right there. And so that's gonna make 4, 2, 1, 3, 5, 6. That's the 1, 4. And then I'm gonna do the 1, 2, swap it. So that says swap the first 2 places. So we got 2, 4, 1, 3, 5, 6. Yeah, let's just kind of do it like that. And then I'm gonna do 1, 6. So that's the first and last items that I'm gonna swap. So that's 6, 4, 1, 3, 5, 2. Swapping those. And then last, we're finally done. We got to the 1, 5, so swap the 1st and the 5th. So we got 5, 4, 1, 3, 6, 2. And so that doesn't look like the original. So hold on, I think we're okay though. Because let's go back to cycle form here. So this says 1 goes to, wait, what did I, this doesn't seem right, does it? What did I, God damn it. I got my formula written down right. So I got 1 and yeah, okay. So what did I do wrong? So did I swap anything wrong? So I started with my original set, swapped 1. I didn't swap 1 and 3.
Yeah.
I swapped,
You missed the one.
I didn't do that one.
Well, yeah, you did.
Yeah, you did.
Going from the top to the second.
Oh, that's right, because this was
Yeah.
for the next set.
Yeah.
Okay, right, so we did 1, 3.
Oh.
Okay, yeah. I got scared though too, Sydney. And then I did the 1, 4.
I got the same thing when I did it, so I got the same.
You got the same thing I got here?
But I got the same wrong answer.
Yeah, and let's make sure that that answer is actually okay. So that says 1 goes to, yeah, that answer looks good. Let's see, what would this be in cycle notation? So this would be 1 goes to 5, 5 goes to 6. Oh yeah, this is way fucking off. What? I'm sorry. Well, that's, what's it? Oh yeah.
I did it just based off of what you said not to do, and I got the answer.
What did I say not to do?
You said that we're switching positions and not
Yeah.
the numbers, but if you switch the numbers, not the positions, you get back.
That
what
actually
we're
works?
supposed to. Yeah. You can check me on that.
Okay, let's try it. Huh.
You can check me on it, please, because.
Yeah, I am gonna check you on it, cause,
Because I thought about doing that, because it gets the 3 in the right spot. for
okay,
one
yeah, let's try this.
From the get-go, and I was like, oh, just
Okay,
keep
so
going.
we go 1, so we swap the 1 and 3.
Mhm.
Huh,
And then you swap like
The
actual
one-
1 and 4.
the actual 1 and the 4.
Yeah.
Numbers, not the position.
Yeah.
Huh, that's completely not what I've been doing at home all weekend, but that's okay, if it's working. And then the 1 and the 2 get swapped.
That's
So-
exactly what you told me not to do.
Yeah, exactly, yeah, literally. And then the 1 and the 6, so 3, 6, 4, 2, 5, 1. And then 1 and, yeah, it's looking good. What the fuck am I thinking wrong? I mean, obviously I'm thinking wrong. Huh,
Good job, Trinity.
yeah, really good job. Let me
She
do the
said-
1 and the 5.
No, I'm
So-
not gonna do what she said.
So 3, 6, 4, 2, 1, 5. Yep. That's it. Well, I guess it is switching the numbers, and that's a little disturbing. Let's try that with the other formula. Okay, good job, Trinity. You're up next. You can just finish this lecture for me. God, if we could just erase. Do you remember when I sprayed WD-40 on this thing?
Yes.
That was,
what?
you were here that day.
You were here. I
I brought
promise.
WD-40 in and I sprayed it all over the board and wiped it down.
I'll cut you some slack, Kyle. Your life is just chaos.
Yeah, so it's all good. It's all good. We'll get you some WD-40. So here's the other formula. So we got A1, A2, A3, up to A sub n. Let's check this out and see if I'm misunderstanding in my description. So this is equal to A1, A2, A2, A3. So you swap pairs all the way down, and then A sub n minus 1, A sub n. So that's another way to do it. So let's check this out. Yeah, and I'm looking at, okay, so let's do that. So 1, 3, 4, 2, 6, 5. So according to this formula, we're gonna swap the A1 and A2. So 3, 1, 4, 2. Oh wait, blah, 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 no. Slow down, big boy. It's 1, 3, 3, 4, 4, 2. Okay, this one seems a lot easier here. 4, 2, 2, 6, 6, 5. Okay, yeah. So let's check that out. So 1, 2, 3, 4, 5, 6. So we swap 1 and 3, and maybe it is the numbers. Yeah. Maybe it is the numbers, because each one of these represents an object.
Yeah.
So, yeah, I guess that's it, Trinity. I don't know why I got myself confused about that, but I apologize and I appreciate deeply your correction. So let's see, so we got 3, 2, 1, 4, 5, 6, and then the 3 and the 4 swap. So that's gonna go 4, 2, 1, 3, 5, 6. Then the 4 and the 2 swaps, 2, 4, 1, 3, 5, 6. Sure is easier this way too, right? 2 and the 6 swaps, we got 6, 4, 1, 3, 5, 2, and then I'm doing it ass backwards.
Yeah.
Son of a
Fucking idiot. Oh my god. Sound like me during practice sometimes.
What's that?
Anytime I screw up a pass, it's normally fuck off Bergmeyer.
Yeah, I call myself a fucking idiot way too many times. My friends and I like call each other fucking idiots all the time. And it's so funny. Like, you fucking idiot, and we just all laugh. Like, yeah, I
It's
really.
even better when you're talking to yourself and doing it.
Yeah. Okay, so switch to 6, 5. Now switch to 2, 6. So 1, 6, 3, 4, 2, 5. Flip the 4 and the 2. 1, 6, 3, 2, 4. 2, swap the 3 and the 4. 1, 6, 4, 2, 3, 2. And then finally the 1 and the 3. We've got 3, 6, 4, 2, 1, 2.
Why do you have 2 2s?
And where'd the 5?
Yeah, that's oh my god. Maybe we should just call it a day. I should just end right here. Okay, so wait, so this was the 6, 5 swap. Let me write shit down. I'm gonna leave a trail of breadcrumbs because I clearly am just like Hansel and Gretel. And I am in the witch's oven right now. So let's see.
5
so
should just stay down the right.
Yeah. Fuck yeah, it's gonna stay there. So there was 2, 6, and then we got 4, 2, right? So 1, 6, 3, 2, 4. Yeah, you guys keep an eye on me, please, guys. I need a chaperone. And 3 and the 4 swap. 1, 6, 4, 2, 3, 5. And lastly, the 1 and the 3 swaps. So 3, 6, 4, 2. And I'll be damned, that worked. Oh yes, imagine. You the king. You king. Okay. All right, well, that was a good review for all of us. Yeah. Welcome to the morning, everybody.
Monday morning.
Monday morning, top of it. Let's work some problems together. Actually, well, there is one thing I wanted to comment. So, notice how when we did it that way, how many transpositions were there? 5. How many here? 5. So that is an invariant fact for these cycles. No matter how you do a decomposition into 2 cycles, the number of cycles is either always even or always odd. And it actually it's the same. Yeah, it has to be always even or always odd. So let's just get that little fact up here. It's one of our big results. We're not going to prove it, but we can kind of imagine how it would work. When you think about how these work, if you have an odd cycle, how many of these things would you have? So here, look, we have an even cycle, 1, 2, 3, 4, 5, 6. We ended up with 5. So you're gonna have 1 less than the length of the cycle when you do this, when you do the pairings. So if you have an even cycle, even length cycle, you're gonna have an odd number of transpositions and vice versa. But let's just put this as a nice result for us. Some pens. So, fact. Every alpha in S sub n can be broken down into a number of transpositions. And when I say number, I really mean composition of transpositions. This number is either even or odd, no matter how you do it. This number, or the number of transpositions, is invariant for each permutation. So this is a distinguishing quality for any permutation. If the number of transpositions is odd, alpha is called odd. If the number of transpositions is even, alpha is called even. So we've got this set S sub n, and it actually breaks in half perfectly to half of it is even transpositions and half of it is odd transpositions, or odd permutations. The set of all even permutations is called I don't know what the fucking A stands for now. So A sub n equals the subset, the collection of all even alpha in S sub n. I can't, like the name is escaping me right now.
Alternating group of degree n.
What is that?
The alternating.
Alternating group, thanks, that's what the A stands for. Yeah, the alternating group. And this will turn out to be one of the key groups that we study, and it actually has a lovely geometric interpretation that we can think of, especially in some of the finite or lower dimension cases. So you know what a tetrahedron is? You played D&D? Yeah, so four-sided, like a four-sided perfect pyramid. Each one of these is an equilateral triangle. Put them all together, you get this beautiful perfect solid. So this is a tetrahedron. And if we label the vertices, 1, 2, 3, 4, the collection of all different symmetries of this thing with itself is equivalent to A sub n, or A sub 4. So A sub 4 can be identified with the collection of all mappings of this tetrahedron back onto itself. And let me just show you really quick what I mean. So for example, I'll definitely need another color here. So for example, and this is going to be like our dihedral group. So take a line, an axis that goes through the center of that face right there and comes out the other side. And then think about rotating around that axis. So that's a way to get this thing to land back on itself. And what is it doing when I rotate around that axis? So like, what if I just did 120 degrees that way, what happens? Well, the 1 moves to the 3 spot, 3 moves to 2, and 2 moves to 1. So that rotation right there can just be thought of as the cycle of 1 goes to 3, 3 goes to 2, and then 2 goes back to 1. But that can be written as just a series of transpositions as well, because we now know that that means 1 goes to 2, and then 1 goes to, and then 1 goes to 3. Using that formula that we just had a little bit ago, or it's equal to 1, 3, 3, 2. That's another decomposition. But notice that that decomposition has an even number of transpositions in it. And everything that you do to this is going to be like that. There's some other things you could do, like for example, let's see, what are the other operations we have on this thing? How else can we move it back onto itself? Let's take a look in the book, because I can't, my mind is just failing this morning. I can't even think of how to map that thing back onto itself. So let's just take a look here real quick. On page 112 is what I'm looking at, actually. Oh yeah, okay, so they're doing like really weird. So like this one, I don't even know if I could draw it. It comes through the middle of this side and then comes out the back straight through. So it's like this pen was kind of punctured right through there. And then we're just kind of flipping it on that. So in other words, it would flip 1 to 3 and then 2 to 4. Can you imagine that? Kind of like flipping it. So how do they draw theirs? Let me draw mine kind of like they've drawn theirs. Well, it looks pretty damn close, actually, but let's see here. So that, and that's clearly off scale because all those things are supposed to be the same. But what we're doing is taking, let's see, so 1, yeah, whatever, doesn't really matter. I'm going to flip it like this so that 3 goes to 4 and 1 goes to 2. Can you see that action on the thing? Shit, I've got a bunch of these at home. I should have brought one. It's so dumb not to. Oh, here, ooh, we can build one. I don't think we can. I don't think I can build one. But do you see how you could just take this thing and kind of like flip it like this, like 180 degrees? Maybe that explains it. Just flip this edge 180 degrees, and then that will flip this opposite vertical edge 180 degrees. So that's another symmetry. And you can see this one is, yeah, I don't know if those pictures help or not, but like look at the second picture on that page. That's what I'm actually trying to communicate, that particular action. How could I not have brought a tetrahedron? Well, because my brain is fried. I don't know how to build one. I honestly don't know. Oh, maybe. Let's see. Do anybody have tape?
I have athletic tape and water.
Shit, there's no tape in there, Sydney. Son of a gun. Let's see, can we do it here?
Walk to the locker room and get athletic tape.
Yeah. So it's like this. Okay, it's like this. I'm just going to show the pertinent edges. So I've got a line that goes from the middle of this marker through this edge out here, and I'm flipping things like that. Can you see? You see what I'm doing? Yeah, does that help a little bit? Yeah? Is that, yeah. Oh, fuck, I don't know. Let's see, so we go 1 to 2. So I want, yeah, that's it, okay. So like that to that. And then these two have swapped positions. This bottom one has gone up, and these two have swapped sides. Like that. There's kind of a little rotation that has to happen at the same time. Boy, this is sad. Your refund will be in the mail. Anyway, so there's that. Here's a great transition. Let's do something else, like get some problems done. I don't have a smooth transition into this. Let's just start doing the problems that I wanted us to work on today. And, because we're not gonna spend another day on this stuff, so that we can start moving on. So page 118 is where I actually wanted to work. And we're just gonna like, you know, do some problems and then strengthen our skills, and apparently I'm gonna strengthen my skills in a much needed way as well. I know I've worked all these already. Okay, so let's actually just take a look at one. Right? Let's just start with problem 1. What about A inverse? Can we find that? We'll come together on the board. I'm gonna try to clean this board with a spray or something. I might go grab some paper towels.
I can go. I need to go to the bathroom anyway, so I could.
Do you?
Yeah.
Oh, that'd be
I'll
solid.
Go to the bathroom, I'll bring some back.
Thank you, thank you.
Oh my goodness. Still blocked.
You sure you can go to the bathroom?
Yeah,
All
I
right.
need to walk it
We
off.
can wheel you there. Kind of, right? It's kind of smearing it as well. That's not bad. Do we have that?
No.
No, okay. Oh my god, I need Kyle now, I can't even write on the board until it's dry. Lord, good Lord, help me. My tip on this is to read the transposition backwards.
So, like 6 goes to 6 and then
Yeah,
4 goes to 5.
there you go.
Okay.
Yeah, and then just write across the top 1 through 6 in order, and then use that correspondence that you were just noting to come up with the new one.
Okay.
Does that make sense?
Yeah.
Yeah.
6 doesn't go anywhere.
Oh, thank you, Kyle. Yeah, I tried with the eraser, but I needed this also. How can that be making it worse?
Oh dear.
Like, right? Like, look. What? It's like some magic picture that you like, it appears. You rub. That is just stupid.
Yeah, let's see them.
How can this happen?
How can this
Should we like just not have class today? I don't know. I don't get it. That's all right. Okay, it really wants to be filthy.
Yeah, that got worse.
It did, it got worse. Yeah.
Considerably worse.
Considerably worse, agreed. 100%.
I can use that whiteboard.
Yeah, I'll have to move my little camera. That's the only reason I haven't yet, Kyle. Just start using up space. Do the colonizer thing.
Oh boy.
Yeah, just consume, move on. So alpha inverse. Yep, read this backwards. So 1 goes to 2, 2 goes to 1, there's a transposition, 3 stays at 3, 4 goes to 5, 5 goes to 4, and 6 stays the same. Yeah. Just to make sure we're all doing good, how about we do one of the compositions? So B.
Wait, so the inverse is the same as the.
Yeah, yeah. And why is that? So why would that be here? Why is that?
I mean, because they're just transpositions.
That's
or
it.
They don't go anywhere. The 3 and the 6 don't go anywhere, so they're just transpositions.
Exactly, it's just a couple of transpositions, so you just do those again and you're back. Actually, instead of doing alpha beta, can we, let's write this in cycle format. Let's just do our own problems here. So what is alpha in cycle format? I'm gonna write cycles in there. But that makes it really clear that it's its own inverse, I think. I think it makes it clear once we actually understand what the hell's going on. Could we write this, oh, we already have it as a composition of 2 cycles. Is this an even or an odd? Where are you getting odd from? So it's the number of transpositions,
Oh, yeah.
right? Because we don't need to write these guys here, yeah? So this is actually an even. And we could do this in a bunch of different ways. It doesn't have to just be in this style right here, but this is an even permutation. What is the order of the permutation? 2. Because that's how many times you have to compose it with itself to get back to the identity. Right, so if I take alpha composed with alpha, then I'm gonna be back to the identity. Let's actually do that, right? So let's write that out, so you can see this, Sydney. 2, 4, 5. So what I'm gonna do is figure out what this is. So let's start with 4. 4 goes to 5, but then 5 goes to 4, so 4 gets fixed. 5 goes to 4, but then 4 goes to 5, and so what comes out this end is still just a 5. 1 goes to 2, but then 2 gets converted back to 1. Same thing for 2, goes to 1 and then back to 2, and then that's it. And the other ones, there's unspoken things here, right? The digits that aren't written are there as well. And so that's an identity. So that's actually our epsilon. Yeah, okay. Cool, cool, cool. Let's see, what other ones that I think would be really good? Yeah, let's try number 5D. So we'll have to kind of put together a few things here. There may or may not be something to do. What is the order of that element? In, what's the guess, 9? Do we have to do much? What do you think, Trinity? Yeah, I agree.
It's just the least common multiple between there's 3 digits and 6 digits.
Exactly, yeah. And we have to make sure they're disjoint. That's the key thing. So as long as they're disjoint cycles, which these are, they don't share any entries, then we just take the LCM of their lengths, so 3 and 6, so 6. This one takes 6 cycles or 6 iterations to repeat, and this one will go through its thing twice on the way there. And then by the time this one's done, this one will flip. It's gone through the identity twice. Yeah. What about number F or 5F? What is the order? 3, 4, 5. 2, 4, 5. Is there something we have to do first just to make sure we're on the right page? What? Yeah. That's a wise answer. Yeah, probably. I agree. What is the thing we have to do before we can answer this question? only determine the order if we know that if they're disjoint cycles. So we have to convert this into disjoint cycles first, that's it. So the first thing is to rewrite this in the disjoint cycle form. So, trace through, where does 5 go? Goes to 2. Where does 2 go after this one? There's a couple things that are going to overlap in here. So see if you can do that to get it written as disjoint cycles. And I would definitely start with 5. Does this look like I did it right? Definitely checking on you all. Got all the digits. Do you want me to go through what I did up here, or is this, or do we agree? Because this would give us the orders too, the LCM of those orders. Do you want me to talk through that, Sydney? You feeling okay about it? Yeah, okay, awesome. And your Trinity, you're feeling good? Kyle, is feeling good to you, friend?
Yeah, I think I got it.
Okay. Cool. Let's see what's next in my little recommended problems list, recommended to myself. Let's look at number 8. I think number 8 is interesting, but let's look at 8. E. So determine if that permutation is even or odd. Now there's a couple of ways you could do this. One is to just rewrite each of these as a composition of transpositions, or first convert it all into disjoint cycles and then do that, but I don't really see any point in doing that. I would just take each one of these and convert it into a decomposition of 2 cycles. Whoa. Crazy, man. Did you get 6? We should all be getting an even number no matter how we do this. Let's check out D too, just for the hell of it. Over here, do a couple of those. D, 8D. Once you get the hang of this, there's not a lot going on. Besides just figuring out what scheme you want to use to do the rewrite. I kind of like this one where you just grab neighboring pairs and write them out. That's easy to remember. And hopefully we're getting that one is odd. This one's odd. This one's even. The number of transpositions is not actually important at all because you can always you can make these as long as you want by just adding more. So like this one here, I could just keep adding some transpositions. I could go, you know what, let's flip 3 and 1 as well, but then I'd have to flip them back to make sure that I still had the same actual action on the thing. So if you flip something that wasn't flipped originally, you have to unflip it, so you're always adding an even number of transpositions every time. So do we feel okay about that, even and odd? Yeah. Kyle, let me know how you feel about that one.
Oh yeah,
Oh, okay.
That's good.
Okay.
I'm doing 5E to make sure I understand.
Ooh, okay. Let's take a look at 5E. Let's do it together. Awesome. I like it. Kyle's assigning problems now. This is great. What was the problem here to do? Is this disjoint or the order? Yeah, the order. Okay. Yeah, oh, I agree. We get the same cycles. And they might be in different order. Don't worry, because these things can literally be cycled. That's the same as this one, and that's the same as this one. These are all the same, so just keep that in mind, because they're a circle. You gotta picture them as an actual circle, and it's just a rotation, really, of values. Do we want to talk about any of this? you got this one, right? I think, or everybody's looking at it,
Yeah.
are we worried that I did something wrong? Cause
No,
I'm at the
right
point where I
answer.
would believe that completely. Is it troubling you? Something troubling you?
Yeah, I just don't know, I don't think I'm doing it right.
Okay, so, let's talk about that more maybe. What's making you feel that way?
Yeah, I don't know, I'm just not seeing that.
Do you want me to walk through it?
Yeah.
Okay,
Yeah.
you got it. Oh, yeah, that's great, that's good, just say that, that's so easy, that's great, help. It helps me to know that's what you want. So, you can start with any number you want that you see. So I'm gonna start with 1, just cause 1, right? So I read from the right to the left and I look for a 1. And I don't run into it until here, but then I see that 1 goes to 2. So 2 gets passed out if I feed a 1 in.
Okay.
Right, does that make sense? So you gotta see that, if that doesn't make sense, we need to talk about it, but if I pass in a 1, this doesn't touch the 1, this touches the 1 and moves it to a 2, so 1 gets shifted to 2. Right. Then I feed in this 2. And I start working through here from right to left, and I look for a 2. I see a 2, the 2 gets sent to a 4 by this one, but then this one's gonna eat it, so potentially move that 4. So 2 gets moved to 4 by this, and now it's at 4. And I keep going, looking for a 4. Nope, doesn't touch 4, so the 4 passes out.
Oh, I see.
You see? And then I feed in the 4, and the 4 gets sent to a 5 by this one. And so now when it comes out of this one, it's a 5. And this one takes that 5 and flips it to a 1.
Oh, okay.
Is that making, yeah?
Yeah.
I would start, so,
Yeah, what were you doing?
I started at the very right, so I started with the 7.
Yeah, okay, yeah, yeah.
7 gets sent to the 2.
Yeah.
And the 2 gets sent to the 3.
Perfect.
Right, and you run back through, okay.
So
Yeah,
you
I
got
would
that.
just,
Yeah.
I was just being silly and I would write in my head without, because I wouldn't go all the way through, I'd write the 7 and then I'd write the 2.
Oh, got it.
It doesn't.
Yeah, yeah.
Yeah.
Trinity?
It's getting there. It's.
Let's try it with Kyle's way, so you can see that, because I think that's actually important. So this could, or we start with, so we'll start with the 7. So, because you're working from right to left, nothing wrong with that. So 7 gets sent to 2, we're cool with that?
Yeah.
And then that 2 gets fed into this one and gets sent to a 3.
Yeah.
And then a 3 comes out. So if you feed in a 7, a 3 comes
We
out.
run into another 2.
Yes,
Before
that's
it's
it.
out, yeah, that's.
Yeah,
Okay,
Yeah,
okay.
yeah. Is that making sense?
Yeah.
Before it completes the whole thing, it hits another 2 and then moves again.
Yeah, and then Kyle's looked like this, which is the same as this. And since they're disjoint, it doesn't matter. These commute because they're disjoint. So I don't know what digit Kyle would have used next, but it could have been this. That would have been great too. Yeah, Trinity, go through it and make sure you're.
I'm trying.
Yeah.
It makes more sense than it did 5 minutes ago.
That's fantastic. Should we do another one? Probably.
I wouldn't be mad if you did.
You would be mad if we
I
didn't.
wouldn't be mad if we did.
Oh, well, you're gonna get mad. Wait, what?
No.
You wouldn't get mad if we did.
Correct.
You're not gonna get mad.
Great. That's confusing.
That was horribly confusing. Cool. Let's shift gears a little bit and then come back to this. No, hell, let's just do the super one that I really, oh, this will be fun. Okay. Okay. So this one's a jump up in the problem set. We're gonna jump on up, and we're gonna look at. Where's the? Oh no, here I don't know where it is. I gotta find it now. I'm not sure where I wrote it down.
Okay.
Oh hell, let's do this one. This isn't the one. I'll look for the other one while you guys are working on this one. So this is number 56, and we're in S100.
Of course we are.
Of course we are. Of course we are. Yeah, keep going, keep going, keep going. It's, yeah. S100. Okay, so we have alpha is a nice rotation of everything to the right in there. And beta sends 1 to 50 and 50 to 100. So the question here is, what is the order of alpha beta? So first we need to figure out what is alpha beta, because they're not disjoint. So we need to break that into disjoint cycles first.
Yeah.
So. This will be good practice. That's a yeah. Where's everybody start? You start with 1. Nothing wrong with that. Nothing wrong with starting with 1. Are you starting from the right? Yeah, cool. Yeah, that's also cool. Because you end up to 1 right away anyway, right? So, yeah. Which one were you? You're starting with the 1 though? Okay, I'll start working with you. But we do have to work from the right to the left, right? So Trinity, what's the next number? Yes! You've got it. Yes.
World. Oh,
55 will get up to 99. So I think this goes all the way up to 99. And then the 100 starts getting weird again, right? Yes. So the 99 goes, 100 goes 1, and then 1 goes to where? It's okay. It's okay.
I was getting it,
I'm sorry.
Oh my lord.
It's a good puzzle. You okay, Sydney?
I think I got it.
What do you think's next, Kyle?
There?
Yeah.
Okay, hold on. So we go 1.
Hold on.
I started from the other one.
Fair
so-
enough.
And then, okay, so you started with 1. Oh no, 1 goes to 50. 50 goes to 1. Okay.
Right, because the 1 goes to the 50, then here this goes,
Yeah,
the
50
50
goes.
kicks to the 51.
And then we got to 100. And then 100 goes, hits 1. And then 1 goes to 2, so 2.
Yes.
And then dot, dot, dot.
Yeah, 3, right, that's just, yeah. Up to where?
Up to, 49.
Yeah, 49. And then 49 goes to 50, which we haven't seen yet.
Right. And then 50 goes to 100. 100 goes to 1, which is the beginning.
Ha!
I hated that.
You can't handle that?
I said I hated that.
You hate it, you
So if
hate
you
it.
start from
Do you understand it though?
That was awful.
Not
100 goes to 1,
particularly,
1
no.
goes to 2. So
No, you're right.
Okay, let me find the worst one.
and then the order of it is what then?
Yeah, what is the order of, it? Yeah. Because that's the disjoint cycle, these 2 original cycles.
Right, like, I just not thought of that. I understand how to get that cycle, and then is what the order is just the product of the two?
It's the
Product of the least common multiple.
Least common multiple of the, yeah.
So that's 100.
100. Yep, so the order of alphabet is 100. Yeah.
Okay.
I'm gonna run through it starting with
The next one, we're gonna go screaming into the night. The next one.
I'd say we're calling it a day, absolutely not.
Now let's do it.
Oh, I can't wait. I love this one. This one's fun.
I can leave here on
You get 5
Fortress
minutes.
or it's
You
I got
get 5 minutes.
Okay, you've only got 5 minutes, so there's stress. Now you're under stress. Fuck it, that's right. Fuck yes. 1, 4. This is number 9. Oh, no, number 9's okay. 1, 4, 5, 6, 2, 2, 3, 4, 5, 1, 3, 6, 2, 3, 5, to the 10th power.
Oh boy, I was okay until you.
Kyle said, no, I got this, I
Write
got
it
this.
as a product of disjoint cycles.
Oh, I started at 2, 3, 4, 5.
You just have to pass each thing through 10 times.
Yeah, nope.
1 through 6.
There's gotta be.
It is just 1 through 6 as well, so.
There's gotta be something behind this. All right, let's start with 5.
There you go. Just look for the rhythm. Come on, math folk. It's a rhythm kick in here. This is a rhythm.
Starting with 5.
Start with 5.
Let's all start with 5, huh? Let's all like take the same route home.
Oh, damn, I'm gonna get all confused again.
You are F-bomb like Lord
I was
today.
reading through the chapter yesterday and I was like, I don't understand.
Okay.
Goddamn thing.
It's okay.
Because when I was coming, like, I
What's the
understand
significance of the 10th?
doing like the
I'll show you in a sec.
that, but any of the cycle stuff
First cycle is.
and how they interact with each other.
Is it feeling better though? It's feeling a little better.
It's better, but it's
Okay, okay.
Okay, so 5 goes to 2.
Yeah, so yeah, let's do
3, and there's no 3.
2 goes to 3, and there's no
Oh,
3. But then I have to do, now I pass it through again. That's
Yeah.
1 power.
Screw this.
3 goes to
What?
5. So you gotta keep
So I gotta keep track of the number of times I've gone through.
I'm
as
gonna
well.
do a little hash
Well,
mark.
yeah, I wasn't gonna say.
3 goes to 5.
everything's
Oh, that's
5.
5 goes to 2. 2 goes to 1. That's the next one.
Oh, okay, hold on. I got.
Oh.
I need to not hear you so I can just.
Okay, yeah, fair enough.
Okay.
Because otherwise I'm not gonna.
Sound like my wife.
Well,
I need to not hear you.
I don't mean that in a disrespectful way. I have to
No,
do it
I
myself to
understand.
learn it.
I
Because
completely
otherwise, if you're
understand.
doing it, I'm
I
not
understand. It's all good.
And now I just,
5 goes to 2.
I lost myself.
2 goes to 1. So
It's easy to get lost.
I have a 1. 1 goes to 3.
I'm gonna start focusing
5.
quietly.
I have a 5, which is what I started with. So if I do 9 permutations, I should have a 5.
I mean, you just keep doing it until you wrap around. As soon as
Right.
you wrap around, you're done,
Yeah.
right? So you don't have to necessarily keep track like,
No, you have 5.
10
And then
times.
What did I have after getting up? 5? Or 5 goes to 2. 2 goes to 3. And the 10th time is a 3. No?
goes to 5. 5 goes to 2, 2 goes to 1.
Because the third time I get a 5 out.
Wait, okay.
Oh, I'm
Okay,
sorry. I wasn't
okay,
gonna
hold
check
on.
my hash mark.
So
Oh, shit.
first time through is a 3. The second time through is a 1.
I think the 5 gets fixed.
2.
Oh, wait, maybe not. No, because it's 10. Oh, you do have to keep track of how many guys
Yeah.
times you go through. Son of a.
Hold on.
Yeah,
Sorry,
yeah,
Mom.
everybody, hold on. Everybody, shut the fuck up.
3, 5. 5, 2. 2, 1.
I'm actually gonna keep
Third
track
time through the 5. So that means 10 times through is a 3, right?
That's 1. 1 goes to 4 goes to 5. Right?
5 goes through 2.
It has to be.
Oh, okay, so check this out. Now look, you go through once, 5 goes to 1. You go through twice, 5
5
goes.
I thought 5 went to 3.
Is that, wait,
5 went to
oh, maybe I got it
5.
wrong. So 5 goes to 2, 2 goes to 3. Oh, shit. Yeah, okay.
And then the 3
And then
goes to the 1. And
Then
then
it
the
goes
1
back to
goes to the 5.
5.
on the next pass.
On the,
Yeah, so the next pass you get a 1 out.
Okay, so 3 goes to 5, 5 goes to 2, 2 goes to 1.
Yes. Okay, and then that goes to a 5.
Then the 1 goes to a 6, 6 goes, wait,
Oh!
Whoa.
1
goes to 3.
3, sorry.
3 goes to 4, and 4 goes to 5.
Yes, sir. 5. Okay, so now look. You go back, this took how many times? 1, 2, 3. So if I do that 9 times, I'm still gonna be at 5. The 10th
and
time
there's
takes
three.
me to 3.
Oh.
Yes.
Okay.
He's done
Oh!
He's done it!
Yeah, yeah. So 5. Yeah, this if you can understand this one, you got it, right?
Wow.
5 goes to, let's just do one more.
One more.
I know you know, I
It's
know.
10:46.
I know it is.
Oh!
Okay.
One more, one more.
Okay.
3 goes to 5.
Do we need to do?
5 goes to
Do we need to do it
Do we need
again?
to
Because
do
it
3
comes
again?
out as a 1.
Oh, we don't. Yeah.
It's-
So we can use this pattern here.
Yeah, and then we
Right.
go through 10 times, and then it'll be a 1 next.
Yes.
And so it's just 5, 3, 1.
Yes. Yeah, because these 3 never become anything else,
And then we
right?
start with a 2.
Oh.
Alright, here we go again.
Let's
Here
go
we go
again.
again.
One
Here we go
more.
again.
Two.
Here we go
Let's
again.
do.
First time.
You can go, Sydney, if you got
Here we go.
it.
No.
This is too much fun.
6
Well, no.
I'm starting as a 2.
2 to 2. Wait.
Wait, 2 to 2. So
Wait,
it's
Wait, well,
actually,
2
I'm
is the easy
second.
one.
It's just 2.
It's just.
Is it?
No, let's
2 gets
go.
fixed? Wait,
I think
2 goes to 3, 3 goes to 6, 6 goes to 2. I agree.
Yes. Okay.
Let's go.
2 is
Let's
fixed,
do
so that's
another
done.
one. Let's do another one.
So the first time through, starting with 6.
That's 6.
What are you doing next? 4?
6.
6.
6? Okay. Okay.
Tell me 1 goes to 4. So the first time goes to 4.
Oh, baby.
Okay, we got
There
a
we go.
loop, right?
Oh,
And then
baby.
6, 4. Let's
Yeah.
go.
6, 4, that's good. Yeah, 6 goes to, yeah, and even, wait, that's once.
Oh, shit. No.
And then 2
So
times
it's
3 is
just
10, so it's a, oh, so it's just
6.
It's just
6
six.
gets fixed because we're doing an even number of
Yeah,
times.
okay.
Yeah.
Do we have to run with 4?
4. We're almost done. We're so almost done.
Well, and
We'll
then,
run it with
and then 4 is
We'll just
just.
double check.
4 must be
4 would
fixed.
be the same thing.
I'm just gonna double check.
Yeah, because 1
Yeah,
goes
but
to
we can
6,
check,
and
but
2
4
goes
has to be
four.
fixed.
Yeah, it has to be. Okay, okay.
4 goes to 5.
Let's go.
5
And then
goes
the
to
else is
6.
3, so.
Spit it out. 6 goes.
Oh, is that what we're looking for?
I think what we're looking
1 goes to 4. Spit it out. Oh,
Ah, problem. Yeah, we're good.
Yeah, okay, okay.
Yep, even number of times, 4 goes back to 4.
So
Okay,
true.
let's go.
Okay.
That was pretty fun. Good job. Good job, my friends.
At least I understand it.
Yes, that's all. That's what I wanted today to be. So how's that? Is that good homework? Was this good homework?
Yeah.
Yeah.
Okay. All right. Part of it was good. Or that's good homework.
Yeah, that's fine.
Do you want homework?
No, no.
Okay. So what I will ask is start reading the next chapter for Wednesday. Yes.
Okay.
Thank you. Please start reading 6.
Oh, 6.
Yes, please. We're getting into some of the meta concepts now.
Meta.
Yeah.
Sounds like a video game term.
It sounds like
This is
something
the meta.
Mark shithead Berg would